All right, we're back again with the algebra final or the algebra final review, I should say. And we have some miscellaneous problems that we're going to do in this. We'll probably get through 15 in this video. And we're going to start obviously with 12 here. And on 12, it asks us to find the sum. So this is just standard polynomial addition. And we need to essentially just combine like terms. And since this is addition, we don't have to worry about there being like annoying negative signs in between the sets of parentheses we have to distribute. So we're just able to straight up combine our like terms. So I'm going to strip out the parentheses, and then we're just going to look and see what terms we have that are similar. So this is actually a lot like the first problem on the test. If we look at this, we're going to start with our 9r squared. We need to look for other terms that have r to the second power, or r squared. That's a regular r, that's a regular number. Oop, that's another r squared, that's a regular r. So 9r squared plus 3r squared gives us 12r squared. We just need to combine the coefficients. 9 plus 3 is 12, but we were counting r squared, so it's 12r squared. So we've got rid of those two. Let's take a look at our 4r. Well, 4r can't combine with -7 because it's a regular number. Oh, we have a minus 3r. 4r minus 3r is 1r, which I'm just going to write as r. I don't think the test will discriminate if you put in a 1r. I don't think it'll compare it to being different than a negative r, than just a regular r. But I would prefer to generally have you put in just r because the 1 coefficient is implied. So we've used our r's. We have -7 left. So -7 just goes to the end. And that's our solution. Adding polynomials is super straightforward. Now, if we were subtracting, it would be a little bit more involved because we'd have to distribute that negative sign that would have been sitting right here, but that didn't happen in this problem. So we're good to go with that solution. All right, 13. This should give you flashbacks to chapter 7 because it's a factoring problem. We need to factor h squared plus 6h minus 27. And in order to factor it, we need to compare this to the standard form of quadratic. And our standard form is ax squared plus bx plus c. And we need to figure out our a, b, and c. Well, our a value is the coefficient on the squared term. In this case, we're using h's. It doesn't really matter. The h squared term goes with the x squared term. There's no number sitting out there on the h squared term, so we get to assume it has a coefficient of a 1. So our h is 1. For our b value, well, we have an x term and we have an h term. So our b has got to be this 6 that's sitting right here. And then our regular number at the end is a minus 27. So our c is minus 27. Please bear in mind, c is minus 27. It is not positive 27. Make sure you get whatever sign is attached to it and include that. If it's a plus sign, it's positive. If it's a minus sign, it's negative. So from here, in order to factor it, we need to do our a times c. A times c in this case is 1 times -27, which gives us -27. And our b is just 6. And we need to come up with some numbers that multiply to make -27 and add to 6. There are only two pairs of numbers that multiply to make 27. One of them is 9 and 3. But in order to make a -27, one of them needs to be negative. We're going to choose the negative as the 3. Because 9 minus 3 is the positive 6 we were looking for. -9 plus 3 would be -6, which would prevent us from using that pair of numbers. So we need 9 and -3 because they multiply to -27 and add to 6. From here, we use this 9 and 3 in order to split up our middle term, which in this case is 6h. So we have h squared plus 9h minus 3h minus 27. Of course, the reason why 9h minus 3h needs to equal, or 9 minus 3 needs to equal 6 is so 9h minus 3h equals the 6h we started with. From here, we need to factor out our greatest common factor. Between h squared and 9h, they share an h. So we pull an h out and we're left with h plus 9. Notice that 9h divided by h just leaves the 9. And then on -3h and -27, they share a -3. So we pull out the -3. And we're left with h. Ooh, -27 divided by -3, that's a plus 9. Got to be careful on that one. Oh, and I got to close my parenthesis. Now from here, we can go ahead and factor out the h plus 9. So that comes out as our first factor. And then our second factor is what was left over, h and -3. And that is the solution to number 13. So you got to remember A times C, what's your B? And don't forget that when it says H squared or X squared or C squared, or maybe not C, but Y squared or something like that, the coefficient on that is just going to be a positive 1. All right, on 14, we're actually looking at simplifying a radical. This is from a more recent chapter. We need to simplify negative 72. So I'm going to go ahead and approach this using my factor tree. So we're going to start with 72. And I'm going to split 72 into two terms that multiply to make it. And the first two terms that come to mind for me are 9 and 8. I should say we're actually factoring 72. The negative sign is just sitting on the outside. So we have 72, and now we don't have any pairs of numbers yet. So now we're going to go ahead and break up 9 into 3 times 3. And we can break up 8 into 4 times 2. And we can still continue to break up the 4. So the 4 becomes a 2 and a 2. This 2 comes down, and the pair of 3s comes down. And now we need to circle our pairs. Well, we have a pair of 3s, we have a pair of 2s, and we have one singleton 2 left over. For each pair, we're able to take one of it out. So we're able to take a 3 out, we're able to take a 2 out, and left underneath our radical is a 2. The negative sign just carried to the outside because it was already sitting there. So we do 3 times 2, which is 6. So we have negative 6, square root of 2 as our answer. Regardless of how you break up one of these numbers, as long as you're doing the correct multiplication and division in order to break down whatever number you're working with, this will work out fine. Just make sure that you multiply when you circle. You take one thing out and multiply it when it's on the outside. Don't add or subtract it. And know that as long as you break things down correctly, you will get the correct answer regardless of where you start up here. It's always a good idea to start looking with small numbers first. So if you didn't know anything that went into 72, you should look at 72 and say, oh, it ends in 2. So it has to be divisible by 2. Check on your calculator, see what 72 divided by 2 is, and then go from there. All right, so that was number 14. We're going to take a look at 15, and I think that'll put a cap on this video. Number 15 asks us to write an equation in slope-intercept form of the line shown. And 2 of the points on the line are given. Now, we need to look at this and figure out what exactly is going on. And what's pretty nice about this is we're actually given the y-intercept. The y-intercept is where a line touches the y-axis, and that's at the point 0, 2. And our slope-intercept form is y is equal to mx plus b. This tells us that the b value of our slope-intercept is going to be 2. So we already know this is going to be y is equal to mx plus 2. But now we need to calculate our slope. And the way we're going to calculate our slope is using the slope formula. Our slope formula is m is equal to y2 minus y1 over x2 minus x1. x2, x1, and y2, y1 come from the points x1, comma, y1, and x2, comma, y2. So we need to go ahead and assign our points that are given to us as being our x1, y1, and x2, y2. I'm going to go ahead and make this one x1, y1, and our 3, 3, x2, y2. It doesn't matter which one is which. You'll ultimately end up with the same slope. You just might end up with negatives on top and bottom, or where the negative sign appears will change. Now, when we plug this into our slope, we get m. Our y2 is a 3. Our y1 minus our y1 is a 2. Okay, great. If we go to the bottom, we have a x2. Our x2 is also 3. All right, awesome. And our x1 is 0. 3 minus 2 is 1, and 3 minus 0 is 3. Therefore, our slope is 1/3. And as a consequence, we have y is equal to 1 divided by 3x plus 2. Now you might be saying, oh, Mr. Sailing, this is so hard. I don't want to go through all this effort in order to calculate our slope. Well, for those of you who are too lazy to do that, you can also remember that our slope m is equal to rise over run. And if we were to compare how many units we need to go up and how many units we need to go to the right in order to find this, we go up 1 unit, that's plus 1. And then we go to the right 3 units, that's plus 3. So our rise over run is also 1 over 3. This only works if you actually have a graph, so you'll need to watch out for that. Also on this problem, you're not actually asked to put in y is equal to. You should just put 1/3 x plus 2. I only wrote that because I don't have a box to fill it in with. All right. So we are going to go ahead and stop this video here. I think that's enough problems for this video. And then in our next one, we'll probably look at 16 and 17 before we have a single video on number 18, because that problem is going to take absolutely forever.